Hi, and welcome to this third video on systems of linear inequalities. Okay, in this case, we're going to look at solving special cases of systems of linear inequalities. Okay, so let's see what happens when we end up with an intersection, or when we end up with linear inequalities that do funny things or do counter to what we think that we should be looking for. Okay, so I have two linear inequalities here. Y is greater than 3x and y is less than 3x. So let's see what happens when we try to graph both of these. Okay, with this one, it tells me that I have a dashed line, and I'm going to shade above. Okay, this one tells me that I have a dashed line also, and less than tells me that I'm going to shade below. So let's graph it. 3x, so that's starting at the origin with a slope of 3, 1. Okay, so that one should be pretty easy to graph. Okay, so I end up with a dashed line passing through these points. Okay, and I'm going to graph this one in purple. And actually it says that I'm shading above. So above in this case would be this way. Above. Why? Because it's still on top of the line, because the line is slanting flatwards, right? It's slanting down to the right. Alright, so I'm shading above. And then now I'm going to graph 3. Y is less than 3x. So basically it's the same dashed line here. Nothing changed. But in this case, I'm shading below. Okay, so shading below. Well, what happens here? Well, we can see that basically the two inequalities are not overlapping. One is shaded above, the other is shaded below. And so the boundary is dashed, and so basically none of the points on the boundary are included. So they share no boundary points. They also share no overlapping points in the region. Okay, so in that case, that means that this system would have no solution. Okay, there's no solution found because there are no shared points found. Okay, let's look at the next one. I have y is greater than or equal to negative x plus 1. So let's graph that one. Y is greater than or equal to negative x plus 1. So I'm starting at a y-intercept of 1. And negative x plus 1, that's down 1, right 1, down 1, right 1. So that one is looking like this. So let me get my inequality graph. And these are solid lines. Oops, that's probably not what I want to do. Let me go and graph these one to one. Let me graph this one up a little that way. Okay, so this one will look like that, and it's a solid region, and so solid and greater than or equal to tells me that I'm shading above. Okay, and so notice that the above and below applies when it's in slope-intercept form. If it's not in slope-intercept form, then you have to do some manipulation, and so your sign could change based on whether or not you end up having to divide or multiply by a negative. So I'm going to shade this one as yellow. And it's above yellow. Okay, there we go. And then I'm going to shade the other inequality. I'll shade that one, maybe I'll make that one blue. And it looks like it has a y-intercept of 2 and a slope of negative 2. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, or up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. Okay, so I'm going to shade this one. This is a solid line also. Okay, and for this one, I'm actually shading below. And this one's not really a special case, but we can look at it anyway. I'm shading below this solid line, negative 2x plus 2. So there's my y-intercept of 2, and up 2, left 2, or down 2, right 2. Okay, so I'm shading below this one. So below all of it, the whole line, the whole blue line, shading below. And so what I get is a little piece here. Okay, so what I get here is the fact that I have I have solutions in this region. Okay, so any of these points, I don't have very many points. But basically also, what I get with this one is I get two solid lines that intersect at the boundary. And this intersection point for the boundaries is 1, 0. And so that's the point of intersection. And if it satisfies both inequalities, then basically the point of intersection is a solution. So let's check that out. 0 is greater than or equal to, I'm testing the point, 1, 0. 1, 0, test. Okay, 0 is greater than or equal to negative 1 plus 1. 0 is greater than or equal to 0. Well, that's true. Let's try it in the second inequality. 0 is less than or equal to negative 2 times 1 plus 2. So 0 is less than or equal to negative 2 plus 2. 0 is less than or equal to 0. That's true also. So this boundary point is actually a solution. So yes, the point of intersection, I'll just say POI, is a solution to the system of inequalities. Okay. Also, I could pick any of these points up here. So let's try negative 5, 10. Okay. Negative 5, 10. Let's test. And so I have 10 is greater than or equal to negative 5 plus 1, which is 10 is greater than or equal to, this becomes 5 plus 1. 10 is greater than or equal to, that should be a 1. Getting ahead of myself. 6, greater than or equal to 6. And let's test it in the second inequality. So we have 10 is less than or equal to negative 2 times negative 5 plus 2. So 10 is less than or equal to 10 plus 2. 10 is less than or equal to 12, and that's true. So it satisfies both of those points. Okay, so basically those are solutions to my system. So yes, this is a solution to the system. Okay, so any point in that green region would work. Now let's say that I had something that's slightly different. So I'm going to come over here, and I'm going to go to my ruled line. And so I'm going to say, let's try, let me view the ruled lines. Let me do some graph paper, because I'm going to create a graph for this one. I don't want my lines that big. Okay, so let's come over here and try this one. So let me add some more room. Let's say that I had let's say I had a system. Y is equal to 2x plus 4. And it's not equal to, let's say I had y is less than or equal to 2x plus 4. And let's say I had y is greater than or equal to 2x plus 4. So let's see how that works out when I try to graph this system. So I'm going to graph, let's drop my axes. Let's go to draw. Okay, so here's my axes. I'm going to zoom out so I can give myself some more room. So let's go ahead and graph those. Y is less than or equal to 2x plus 4. Well, I have 1, 2, 3, 4. And less than or equal to 2x plus 4, so I can go up to right 1, or I can go down to left 1. Down to left 1, and it'll get me to the same place on the same line. And so this is a solid line, right? Because this tells me that this line will be solid. And it also tells me that I'm going to shade below. Okay, so let's go ahead and do that. Let's go ahead and shade below. Let me actually put my arrows because that line continues on forever. I'm going to shade below this line. See if I can do that a little nicer, a little neater, closer to the line. Okay, so basically I'm under the line, below the line. Let's see if I can fill that in. I'm a bit of a perfectionist. Okay, so then now I'm going to graph the second inequality. So let's try that one. Y is greater than or equal to 2x plus 4. Well, it looks like it's the same line. Y is greater than or equal to 2x plus 4. They have the same boundary. However, for this one, I'm shading above. Okay, so it's still a solid line, but I'm shading above. So let's go ahead and shade that. I'm shading above this line instead of below it. Okay, so what happens here? In the other inequality above, right, let's zoom out so we can see the one that we did before, we noticed that there was no solution because they didn't share any points. Well, this inequality these two inequalities actually do share points, and they share all the points that are on the same line. Okay, so in this case, the solution to this inequality, I could test any point on this line and it will work. I could test a point in the orange region and it won't work. Let's test it and show you just to make sure. Let's test 2, 2. So y is 2 less than or equal to 2 times 2 plus 4. So it works for this one. 2 is less than or equal to 8, but then when we test it for the second one, 2 is greater than or equal to 2 times 2 plus 4. And so that is 2 is greater than or equal to 8. Well, that's not true. So that makes the point 2, 2 not a solution. No, that's not a solution. Okay? And then if I test a point up here, let's try 3, 2. So I'm going to 3, 2. Test. Okay, so when I test 3, 2, I'm going to put that in. 2 is less than or equal to 2 times, I'm sorry, that is totally wrong. What am I saying? I know better. Okay, I'm going to test negative 2, 3, excuse me, negative 2, 3. Okay, so hopefully that didn't confuse you too much. Okay, so 3 is less than or equal to 2 times negative 2 plus 4. And so that's 3 is less than or equal to negative 4 plus 4. So 3 is less than or equal to 0. Well, that's not true. So I know that because it doesn't work in both inequalities that it won't work out. But we'll test it just to see if it works in the second one. Remember that it can work in the second one because that's including the second region, right? So if I were to put that in, 3 is greater than or equal to 2 times negative 2 plus 4. That would be 3 is greater than or equal to 0. And that's true, but it's not true here, so that makes this a no. No, it's not true. But what is true? Let's test a boundary point. Okay, so boundary test. So when I test the boundary, I'm going to try the y-intercept. That's easy enough. So let's test boundary test 0, 4. Okay, so when I plug that into both equations, if I plug it into the first one, I'm going to get 4 is less than or equal to 2 times 0 plus 4. So that's 4 is less than or equal to 4. Then I'm going to test it in the second one. 0 is greater than, 4 is greater than or equal to 2 times 0 plus 4. So basically we're getting the same thing. 4 is less than or equal to 4, and 4 is also greater than or equal to 4. Why is that? Well, because 4 is equal to 4 in both cases. Therefore, any point on the boundary satisfies this inequality. So the solution to this inequality, in this case, the solutions are just the line y equals 2x plus 4, because only the points on this line will satisfy both inequalities. Okay, so this is a bit of a special case, one you see occasionally that comes across in an inequality, but hopefully you get enough practice and familiarity with graphing inequalities that these special cases don't bother you, that you're able to think through them and solve these types of problems. All right, I hope this video has been helpful. See you in the next one.